This is the continuation of the previous video. So before I make a video on understanding this document about Mifare Ultralight C, I would like to cover a few more points about this tag. And if you are able to understand this document on your own, probably you don't have to see my next videos. Now, as I mentioned before, Ultralight C learning feature is available in version 1.4.1. So I'm going to place a brand new tag and choose the tag as Ultralight C. So I have covered most of the points in the previous video. So in this video there are a few things I would like to show, especially the counter. The way the counter works in Ultralight C is a little bit different from the tags like ntag213 or the Ultralight EV1. I'm going to get the content of this entire tag. The documentation says the counter can be initialized only once with any value we want. So remember, the counter is just a 2-byte counter, which is the bytes 0 and byte 1. So byte 2, byte 3 is not used at all. So there is no special command for the counter. If you have seen my videos on Mifare Ultralight EV1, there was a command to read or increment the counter and read the counter. There's two separate commands. Whereas here, reading, writing and incrementing, they're all done using the simple or the same write page or write command. So I'm going to initialize this counter. The reason why you have to initialize the counter is after the very first writing to the counter, you cannot write more than the value 15, or you cannot, you cannot increase, because the counters are the increment counters, the incremented values. So you cannot decrease the counter. You can go only in one direction. And obviously, when both the bytes reaches their maximum, that is all hexadecimal FFs. Okay, so when both the bytes are FF, so you have reached the limit of the counter. So any further write in that case will throw an error. So the way you do that in this software is, so whenever you click on this grid, the corresponding values are shown here. So page 41. So I want to first write, say, the number. Assume that we want to write number 10,000. This is my initial value, or it could be 20,000. But keep in mind, a 16-bit value gives you probably 1667, I suppose. 67. And also this is an unsigned number. This has to be, I'm sure the 16-bit number you can go up to 64,000. Sorry, the 32,000 was a signed number. But so I'm going to initialize this counter with the 25,000. Now this is the hex equivalent of 25,000, and to understand, I'm going to clear these instructions here, the command, sorry. So first I'm going to write. So I have written. So if you look at the command that's gone, what I'm also doing here is, after the counter is written, I'm also reading it back. So you can see the write page 41 and the read page 41. So here the counter value is A661, and also I'm refreshing this screen as well. So the count is 65. So after that, it has been written now. So assume that I'm going to probably now reactivate. So you can see the counter is 25,000. Now I'm going to write. Just see what's going to happen. I'm going to write the value, say 1000. So this is not the best value. For example, try something with the 0 3 and say D2. Okay, let's see what's the numeric equivalent of that. So it's too much actually. Just try 0 3 0 3. Yeah, if you look at here, I'm trying to write 771 to this counter. So obviously you will think that after you write, the counter will be 771 more than 25,000. So it will be 25,771. So let us see what's going to happen. So remember, this is the lower byte, this is the upper byte. Okay, so it's 0303. So when I write, if you look at that, so what has happened in we wrote 3303. Look at that, what the ULC tag has done. So after you read the counter back, you can see that the counter has increased only by the value 3. That is only by the value you put in the first byte. So this shows after the very first write, all subsequent write will only increase up to the 40, is up to the 15, the maximum 15. Okay, so that's one thing. Let's try to write something like FF here. So what's going to happen? This number will be 1023. Okay, so this is the decimal equivalent of this. And what would expect again let's say it will take only the lower nibble. Okay, so obviously what you have to keep in mind is we are trying to write FF03. So this is a big number. Now what the ultralight tag is going to do is it is going to take only the lowest nibble of the first byte. It is going to ignore this, it is going to ignore that. So it is just going to take that. Okay, now let's write. I'm going to write. See that this has become 18. So let's go to restart this and try again. So this is something different, okay, from any other the later tags. Look at that 18. Okay, give one more example and then we'll go to the next concept. So this time I'm going to write with the say D700. This can be anything, doesn't matter. I can also write FF, doesn't matter. Now what we expect here is we are trying to write D7 F and F. Now this is the lower byte, and what the ultralight tag is going to do is it's going to just take the lower nibble, okay, of this byte, which is 7. So only 7 gets added to this number. So right, you can see that from 18 it has become 25. Okay, so that is all you have to keep in mind about the counter. And also keep in mind there are no special counter commands in Ultralight C. So next I would like to show you how to use this the dynamic locking features. So in my previous video I mentioned that the Ultralight C tag has got more user memory or more pages, so you need extra locking bytes. Now here each bit, say for example again the first 2 bytes, okay, B0 B1 is what is used for the dynamic locking, and if you read the documentation it's clearly mentioned how each bit controls the locking. So here I'm going to write, before instead of just locking, probably I would write something to this entire tag. So just like in my other tags, you will see this string write feature. This is where you can write a bulk write the text here. So probably when you use this in your software, probably you'll be writing, say, the name of the person, his address, and probably is some kind of a employee number or some kind of a ID number. You write everything, you write it to the tag, and you can lock it. So usually, okay, in practically, okay, we don't just write the name as it is. So you just encrypt it. Okay, probably I'll make some other videos on how to encrypt using the UID. It's called UID diversification. So I'm going to just get some lorem ipsum. So if you're a software developer like me, you must have already used this lorem ipsum. You know, this is a fantastic website to get some random characters. I'm going to grab a few lines of text and I'm going to paste here. So what I've done here is, you know, this ultralight tag has got only 144 bytes of free space. So I've just made a limit for this text box. So probably this text box size is not, it's too big. So this is the 144 bytes. So writing or using this string write tab. So if you want to transfer this data to the ultralight tag, it is done in 2 steps. First you type the data and transfer using this save to the page. You transfer to the grid which is within the software. I want to transfer everything from page number 4 onwards, transfer it. So you can see everything is transferred here, but it's not written yet. Now I'm going to clear this command. Now I'm going to write everything from page 4 to page 39 because this is the entire 144 bytes, so which has taken space from page 4 onwards up to the page 39. So remember, soon after the page 39, all these special pages starts: dynamic lock, counter, the auth 0, auth 1, and all the 4 keys. So right, so its writes is successful, and if you look at what is going on, you see so many write page commands. So you just have to, there's no way you can make this faster. So we have written something. Now assume that after we wrote, so I want to lock the page number 36 to 39. So because this is in the extended memory, you are going to use the dynamic locking. You cannot, one thing to keep in mind, you cannot just go and lock page number 35 alone. It's not possible. Sorry, page number 36 alone. It's not possible, because if you want to lock a single page, you can do that only within the first 15 pages, because the first 15 pages locking is controlled by the static lock, okay, which I have made so many videos explaining how the static lock works. Whereas all the memory after this page number 15, it's controlled by the dynamic locking. So I want to lock the last 4 bytes, 4 pages. So you're going to put a tick and say write. So the software says it's locked, and let us see what's going to happen when if I try to write to this page. Okay, now do we get error or not? So again, this software cannot do any magic. Everything goes according to this documentation. So this documentation, it's you have to read it. Okay, it's a very nice documentation to read about. Now I have just locked the 4 pages. Let's try to write now. I'm just going to move. Okay, now I'm going to select this page number 37. The user data will auto populate. Go to the hex. This is a feature where you can use the hex mode and ASCII mode. So go to page number 36, and I'm going to change this to not number. Go to text. I can change it to A, B, C, D. Now because this is all done by the software, knows this page is locked, so the write is disabled. Click on safe mode off. So this shows the safe mode is off now. So this button is enabled. It's just a simple it's just a trick is done here. So let's clear all these things. Right, now it says write is successful. So this, we just don't know whether this is really has written something, or in order to prove that, just try to read something from the card, or give a new command to the tag and see what happens. So all these, the last column here, you got this R. Okay, you can click that, this reads a specific page. Now because if you hit this read tag, you try to read the entire page. If you read this, click on this just a link R, it reads a specific page. Now I'm going to read this again. So if you're able to read, then the locking is not affected. It's still it is the documentation probably says the locking will be effective, the dynamic locking effective only when you restart or when you reactivate the tag. You can see that I'm able to read, the read is successful, and let's try to change as well. That's interesting. Now I'm going to, we changed it. Okay, so even after the dynamic locking, I'm able to write, I'm able to read. So the lock is effective only after the next reactivation. So I'm going to close. So I'm going to place again and reactivate. So read everything. If you go back to page number, you can see here the page number 36 is been modified. If you try to modify now, go to this safe mode and try to modify the page number 37. Give E, F, G, H and say write. The write is successful. However, we know, we have seen this problems in my earlier videos. If you try to read something, you get an error page. Okay, so this shows the previous write command was not successful. If you go and look at the status, there is already an error. So timeout, the target has not answered. So what we have seen just now is, after you use the dynamic locking, okay, you have to reactivate the tag in order to make those locks effective. So this concept will apply for anything. Now the only way, because the tag is in the error state, it has gone back to the idle mode. So I'm going to reactivate, then read the tag. Now, so I wanted to show you the counter. Now this bit says log the counter. Let's try to do that. Again, keep in mind what I'm doing here, okay, just like a freestyle of writing. There is no authentication required, so you don't see these things, okay, in the real life. So any tags that use, any application that uses ultralight tag will have most of these features will be locked by a password. Now because this is a learning tool, you should know how this thing work first. So if I put this L41 counter, so I'm going to put a tick and say write. So this means the counter is locked. Now let's give it a try, understand this concept. Let's try to increment, sorry, I didn't show this feature. I'm going to increment the counter by 5, right? Now write is done, read is done, everything is fine. So this again goes back to what we discussed just before that. The lock is still not effective. So I'm going to take this RF off. So this tag is not powered, and you don't have to make RF on, because the ACR122, as soon as you try to activate a tag, it will automatically brings that antenna on. So that's what it should be doing. So so it is, that it's able to read it. Okay, now try to increment this counter. Just go to the dynamic log. Yeah, it's locked is true. Now write. Now the counter failed. It's interesting here, because as soon as we try to write, you got error. No, I don't think so, sorry. Yeah, so if you look at the last two commands, sorry, I was wrong. The write counter says it's successfully written. However, when you try to read the page, it failed. So this command, even though it failed, the PCSC does not return, the command has failed. I'm not very sure whether it is because of PN532 or because of this ACR122. So probably now in my I also have the same software which works with the PN532. Probably we'll come to know there which is the one that's doing this. Okay, so this is you can't write anymore. Again, activate. Okay, that's it. Next, what I want to do is I do not want, so go back to hex. So if you look at this BL, block the locking. So what I want is, so I don't want anybody to lock the pages from 32 to 35 and 28 to 31. So I'm going to take this as well as, sorry, sorry, I was wrong. So this single bit here, okay, you can use this single bit to block the locking of page 28 to page 39, right from there to here. Okay, so if I put a tick here and say write, so what I have done is, now I have told ultralight tag that nobody can lock this anymore. I've just said that these three tick boxes are completely frozen. Okay, nobody can change this anymore. One thing is sure, you cannot change even the software. I think there must be a small a bug here. Usually this should avoid. Or I don't think, one second, I think this is because of this safe mode off. Okay, go to safe mode on. Yeah, that's it. So see, in the safe mode on, so this tick has made these three lines red, because this bit controls anything from page number 28 to 39. So they say you cannot make any changes for this log bits. So that's what the block locking is all about. Now let's give it a try again. I'm going to deactivate. Okay, let's see this. Okay, now I'm going to lock, just try to lock it. I'm going to say lock this and lock that. So let's see that we have changed our mind. So we wanted to lock page 32, 35, 28, 31 as well. Give a write. Now the write is successful, but try to give a read command. You can just delete probably this one. Yeah, I can just delete as well. So give a read. Okay, there's some more issue as well. Okay, so give the read failed here. I can see. Okay, the read failed. So however, why I'm showing read? Okay, if you see that, okay, after I think it's not an error. When you read the tag, you know that these two has gone back to the earlier state. So what you have to keep in mind is, the block locks assume that, let's try to do it again. So I don't want anybody in the future to lock all these pages from 16 to 27. I can just put a tick here and say write. Okay, so nobody can lock the page from 16 up to 27. It's completely it's frozen. Okay, so nobody can lock it. So the next thing is about, likewise you also got locking the configuration. This is what you'll end up doing when you finish your software development using this tag. You write everything you want to the tag, you set the keys, and you lock it. That's what I'm going to do now. Lock it, freeze it, everything. Okay, assume that, let's pretend that we have done with this. So I'm going to change the key to, I have to copy paste here this, and you have to be careful before you make this tag read only. I think read only is the word used to do this type of configuration. So you're going to make this tag complete read only. First I'm going to change the key. I've changed the key. Then I'm going to protect this tag. So before that, just say that okay, I want to protect just the write operation of this tag. So I don't want anyone to write to this tag. So I'm going to change this auth1 to write only. Write it. Now that is done. And now the last thing you're going to do is I'm going to protect everything from page number 3. From page number 3 onwards, everything okay is protected. The write operation from page number 3 is protected by the password. Once you do this is in auth 0. This page number is over here, auth 0. So write. Now look at the software is already showing this, it's all write protected. Now let's give it a try. So this is the this is the final state of this tag. Activate, read. I'm able to read, it's fine. However, we're going to write. So you can see that in the two concept here, one is the lock concept and the protection concept. Okay, the locking is completely locked forever. Now in the configuration, what we are completely frozen. See, you could have locked auth1, auth 0, you could have locked that, which I haven't done. Okay, now in order to make any changes to these pages, you have to first authenticate. So our password is this. Okay, oh sorry. Now keep in mind, when you enter the password in this software, you have to use a dash here. Now I'm going to first authenticate. Now authentication is successful. And also before I finish this video, just want to mention about this this password, the way it's stored. So you can think this as a higher byte, this as a lower byte of this 8-byte sequence. So the lower byte, okay, is stored first, A7, A6, A5, A4, A3, A2, A1, A0. Okay, and this is authenticated. Assume that say we have changed our mind, okay, and we also want to log this configuration. Nobody, even though somebody comes to know the password, we don't want them to change this configuration anymore. So I'm going to log that. Probably you can also lock it. I don't know if you can. Yeah, you can also lock the key as well, so nobody can change this key further. Okay, now if you're making this tag read only, now you can just put a tick. All the ticks is fine, right? So the write is successful. Now let's reactivate this tag and see how it looks like when you read again. Okay, now password cannot be changed. Now what will happen if the password if you try to change the password? So I mentioned about this as well. So let's try to write first. I'm going to write to any page which is protected. So go here, go to random page 4 and put say text as A B C D. Right. Okay, this is the software message. So I'm going to go to the safe mode of write. See, the write is successful. Okay, we know that, we have seen this in my earlier videos. If I try to read, the read has failed. Okay, so writing to a protected page without authentication, okay, so that will make this tag fail and go to the idle state. Now the best way to do this is soon after write you can also do a read operation, so rather than going through this multiple step. So just now we saw that we can't write without authentication. Now I'm going to authenticate. authenticate. So authentication is successful, and now I'm going to the same page and do some writing. Go to page number 5, do some A, B, C, D. Okay, the write. So the write is, again, you don't know, just go and try to read something. So read did not throw an error. Probably I was expecting, a message here which is not coming. Probably that's a software problem, but the read is successful. Now let's try to change the password itself. So I'm going to revert the password to factory setting. So there's an interesting, if you look at this password, the actual the ASCII of the password, it's very interesting. I'm going to show you in my next tag. This I can't change. So I'm going to change the password, the key of this tag, and see what's going to happen. Write, yes. Now write immediately failed. Okay, so let's see where exactly it failed. The first write operation, look at here, the first write operation as usually now got a success. The second write operation failed. The third onwards everything got failed. Okay, so if you look at this get status, you can see there is an error in PN530 reader. So this shows now you cannot write to a protected page. So I'm going to place one more tag and activate this and read, and I'm going to authenticate using the factory default password. Now authenticate successful. Look at that. If you go to ASCII mode, so look at that, what exactly you say, this 49454D, it says break me if you can, exclamation mark. That's interesting. Okay, so the reason why the Ultralight C are very popular is because of this Ultra 3DS case.